So here is our Math 20 practice final. Again, I got here by going to Math 20, and then at the bottom, going to final exam. One of the things you're able to do as a class participation achievement is 6 practice finals, and they can be from Math 20 also. If this is something that helps you feel good about your math foundation, then any of the 6, as many as you want, could be from here as well as 25. Obviously, doing them for our class is something you want at least some of them, but... Okay, I don't care about this too much, but it's good for a warm-up. So let's pick a few of these, and since it's the first class of the week, get our brain thinking about math, since we've just been doing announcements until now. Which one should we do?
Number 2 on the board.
Number 2? Anyone want number 1 before we go to number 2? Number 1? Okay. Let's do both. So the prime factorization is the name of sort of a game to play with numbers. It involves this tree. Does that ring a bell? Factor tree. So I'm going to start with a number. And then I'm going to find factors of it. Factors being numbers I can multiply together to get back to this thing I want. So what are 2 numbers that when I multiply them together turn into 104?
52 and 2.
52 and 2. Yes, you can always say, let's divide it by 2 because it's even. I can keep going. What's half of 52?
26.
So this one was only 2's and something else. Oh, okay, there we go. So how many 2's were here? 3 2's. What if I started a different way? I could say, let's divide it by 4. 4 quarters makes $1, so that would be 4 times 25. And I have another 4 after that, so 4 times 26. Well, then I have to take that 4 and keep breaking it up. On each branch, I keep going until I get to prime numbers, and then I can stop. None of these factor trees would answer the question, what are all the factors of 104? The first tree doesn't have a 4 on it. My other tree doesn't have a 52 on it. So I need a different game for a different question. If they're wondering what are all the factors of 104, I need a different thing to do. But for what's the prime factorization, then this is the game. It doesn't matter which factors you pick, they will all eventually get to the same list. A couple of details. You've noticed I circled the prime numbers, the leaves on the tree, because it's really easy when you're taking a test and your brain shuts down to just forget one and not see it and count only 2 of them instead of all of them or something like that. Another thing that people sometimes do is instead of circling them, they'll just bring them down to the bottom so that you can read across the bottom what they all are. Just looking at what makes people happy in the past terms I've taught this seems to be the more common style of circling, but they all, either way works. Okay, how do I know that 4 goes into 104? Let's talk about the divisibility rules for a moment. Come on, there we go. For some reason, our school system teaches some of these but not others. I have no idea why, so let's talk about them. Most people show up in Math 20, Math 25, knowing that the first 3. Our number we had a moment ago was 104. Does it end in a 0, 2, 4, 6, or 8? If so, we call it even. 2 goes into it. If it ends in a 0 or 5, then 5 is a factor. If it ends in 0, then 10 is a factor. There's other rules that aren't any more difficult, but for some reason people don't get taught them. If I take these digits and add them all up, so 1 plus 0 plus 4 equals 5. Now, does 3 go into 5? No, so 3 is not going to go into 104 either. Do 2 and 3 both work? No. If they did, then 6 would go into my original number. But in this case, 3 doesn't work, so 6 won't either. If I just look at the last 2 digits, does 4 go into 4? Yes, so 4 goes into my original number too. And back to that sum, does 9 go into 5? No, so 9 is not going to go into my original number either. So let's do that with a bigger number, 13,512. Okay, is 2 a factor? Yes, because it's even. Is 5 a factor? No, because it doesn't end in 0 or 5. Is 10 a factor? No, it doesn't end in 0. Oh, now I have to add things up. 1 plus 3 plus 5 plus 1 plus 2. So 4, 9, 10 is 12. So does 3 go into 12? Yes, so 3 goes into my original thing also. Did 2 and 3 both work?
Yes.
Yes, so 6 goes into my original number. If I just look at these, does 4 go into that? Yes, so 4 is fine also. And does 9 go into 12? No. So when I'm doing not long division, when I'm doing factor trees, then I could always peel off the smallest number possible, like we were doing 2's. But if I wanted to take a bigger chunk, this helps me see some slightly bigger numbers. It's also useful when I am doing fraction reducing. If I'm looking for the same number that goes into the top and bottom of a fraction, so I can divide top and bottom by something and reduce my fraction, I can get slightly bigger things with all these tricks in my brain.
I'm confused about, it says a number is divisible by 4 if the 2-digit number formed from its 10 times digits. So
Yeah,
it would be...
so I'm just ignoring everything but the tens
Okay.
ones. What are those two? Might help if I do that. Okay, so that was problem 1. Problem 2. Okay, 8 times y is 768. I have something stuck onto y with multiplying. How do I get y by itself?
The opposite of multiplication. So divided by 8.
Yeah, so I need to do orange. Divide both sides by 8, and then I'll have y by itself somehow. What I don't want to do is try and squeeze some long division right there on the page. That's going to break my flow of things. So I'll come off to the side, assuming that I'm doing this by hand, and say, what's 8 goes into 768? Doesn't do 76. Sure, 9 times 8 is 72. 6 times 8 is 48. I'm done. In this class, unlike Math 20, you're always allowed to use your calculator. So there's really no need for you to do the long division I just did on the board. Let's make it a little different. What if we had a fraction there instead?
You can times it by the reciprocal, or you can just divide it by 3.8.
Yeah. With my calculator,
Upside down.
I don't have to worry about how to divide fractions. It is true that you can multiply by the reciprocal to divide fractions, but I don't actually even need to worry about that. How do I do 768 divided by 3/8 on my calculator? So take out your calculator if it's not out. If you have a modern calculator, it has a little button that looks like A, B over C. Everyone find your fraction button. 768. So the AB over C, you press it if you have a mixed number in between the whole number part and the numerator. And if you have a fraction at all, you can push it in between your numerator and denominator. So in this particular problem, I can say 768 divided by 3, use my AB over C key for the fraction bar, and it will just put out my answer. $2,048. Everyone got the same thing. So
Can you change it to a decimal?
can you change it? Yes. Let's do one where, because this button has another power. So let's do another one. Everyone okay with this one before we go on? You either got your calculator to do it, or you want a fancier calculator. No, that's right. 2048.
An error that pushes that back fractions.
Does that one have a fraction?
I don't see one.
I don't either. That's why TIs aren't what people like. Oh, good.
Got it off Craigslist.
Okay, let's do one where the answer is a fraction. How about 1/2 times, oh no, let's make it smaller. 1/8 times 2 1/4. There we go. So there's lots of ways to do this. If you've used these decimals a lot, you might just say 0.125 times 2.25 and so on. But let's assume we're using our fraction key, because that's our theme for right now. Can I make that bigger? So I would type in 1, then use my fraction key, then multiply. Now I'm going to use my fraction key twice, once to separate the whole number from the fraction part of the mixed number, and then once as the fraction bar. Make sure mine works. I'm not getting the right one. Let's see. 1/8 times 2. I'm confusing myself. Okay. So what it puts out for me is 9R32. So what it's saying is that my answer is 9/32, which probably isn't what you want in any practical application. So if I take that and I hit my fraction button again, it switches to a decimal. And I can push it again and it switches back. So a second use of this is once you have an answer and aren't in the middle of typing in the problem, then you can use it to flip back and forth between your decimal and your fractions.
Wait. That's the answer?
Yep. Do you want me to do it out by hand so you see?
Yeah.
Okay, it is a good problem for review. So how do we actually get the 9/32 if we were to do this ourselves? Okay, first I'm going to get rid of the mixed number, because mixed numbers are awful. They're convenient when baking, but except for that. Or carpentry. Anyway, so how do I change 2 1/4 into an improper fraction? Yeah, I see lots of people making the shape.
You do 2 times 4 plus 1.
Yeah, 2 times 4, and then plus 1. Okay, now I'm needing to multiply fractions. I wish it would let me make my dots bigger. Are the dots okay in the back? Can you see them? How do I multiply fractions? Yeah, straight across, top and bottom. So 1 times 9, 8 times 4, and I get 9/32. I might not be done. There's that silly rule that fraction answers aren't finished unless they're reduced all the way. So that's why our divisibility rules that we went over a moment ago are useful. Is there anything that's a common factor of 9 and 32? No, so we're done. You're welcome.
So when it says 9R32, that's just 932. Okay. That's easier. No.
Okay, let's do math 25. So I had asked you to look at number 14. We have a runner and a walker. And so part A will be our runner. So running is 0.09. So our runner will burn 405 calories. Then half of that is fat and half is carbs. So we'll take the 405 split it up half and half. There we go. So we'll get about 202, 203 of each. Let's see. Okay. Our walker is pretty much the same, except that now we're using a different number. Whoops, 0.039. Typo. So that's about 176 calories. Now that doesn't split half and half. When you're walking, then it's 3/4 fat, 1/4 carb. Why is it doing that? Stay there. Oh. So 176 times 0.75. Okay, everyone got the same answers when you did it yourself? And the moral of the story was, even though you burn a larger percentage when walking, because your body is not needing the instant energy from carbs, overall you're going to burn more fat running just because it's more intense. Any questions on that one? So, where are we now? Aren't you scrolling? There we go. Did we do the calories in a day? That's where we stopped, right? Yeah. Okay. Did we do the calories in food? No? Okay, so that's where we stopped. Okay, thank you again for being guinea pigs in the experimenting and learning about those formulas and things like that. Now we'll talk about food. I brought some food. We want to do vegetable trimming today, but we had so much announcements in review, I'm guessing we'll just do that Thursday. Is that okay with everyone? Thursday is also strange because it's a no school for kids day in 4J. I'm not sure about Springfield. Yeah, just don't be messy. Is anyone else going to bring kids on Thursday? No? Okay, I might bring mine. Let's see. Okay, they can play with you.
Can I bring my dog?
Can you bring your dog? That I don't know. I've never had anyone ask me that.
So how old are your kids?
8 and 11.
Oh, they can probably teach us.
So they'll like playing with you. Okay, so calories. We talked about burning calories with exercise. We get our calories with food. And it's kind of remarkable that there's only 3 categories: carbs, and protein, and fat. Carbs and protein have 4 calories per gram of weight of the food, and fats have 9. So there's more energy in a little bit of fat than in the others. So we can do some easy math with this. Arthur's in a rush this morning. He eats the bagel, whose nutrition facts are there on the board. How many of the bagel's calories are from carbs? Well, it doesn't tell us that. So I'd have to take this 47, multiply it by which number? 4. So 47 times 4, and I get 188 carb calories. Okay, from proteins, I'd have to take that 9, multiply it by 4, and I'd get 36 protein calories. And from sugar, sugar is a subcategory of carbohydrates. So it's going to use the same 4 as the carbs. And I'm just going to overwrite the percent because it will be easier. Okay. So that was number 16. Number 17, the bagels package says that it has 1 gram of fat, so we'd go times 9 and get 9 calories. But it also says that the calories from fat is 13. So what's up with that?
It's a bagel, so it's going to be different depending on what bagel you choose.
So they should all be the same bagels in the bag. What's your...
2 saturated fat. It's a little bit more, so it has 1 whole
That's
gram.
part of the total fat. That's not extra.
Cheating is already in the answer.
Oh, you looked ahead and... Okay.
Well, yeah.
Go ahead. You can cheat for us.
No, that's okay. It's something about rounding up, but I can't remember exactly how it goes now.
What would the number here need to be if times 9 is 13? If I do 13 divided by 9, what do I get?
Roughly 1.5.
Right.
Yeah, a little less, like 1.4. So this number here is actually supposed to be 1.4, but they just rounded on their package. And they're allowed to do that. It's not like this is some dishonest marketing. Okay. Milk has different numbers. I didn't bother to make a pretty square, but we can do the same stuff for milk. Oops. So for the fat, we'd have 5 times, not 4, times 9 is 45 calories. For the carbs, 12 times 4 is 36 carb calories. Oh, I'm sorry. Thank you. I was thinking I should change that to say fat calories because they're all over the place. And then new color. 9 times 4. Okay, so this is easy. You can multiply by 4, you can multiply by 9. Nothing too exciting. I'll skip 18 just because of our time. A separate thing about calories and food is how much you should eat. So the USDA has these recommendations. Whether or not you can trust them is a health issue beyond the scope of a math class, but we're just going to assume that they are good for now. And they will say if you have a 2,000 calorie per day diet, then you should eat this much of carbs and protein and fat. If we're working with this, again, just taking it on face value, not arguing about if it's a good recommendation or not, then we can do the math of, I ate something. How close to my daily amount have I finished up eating? So, to find a percentage, we take our part and divide it by the whole amount. When we do part divided by whole, we get a decimal instead of a percentage. So we have to change it to be a percentage. We do that with scooting the decimal point, scoot it 2 places. And the acronym that helps us remember that is RIPLA, right into percent, left out of percent. So we're going to do all of those things together. So Odette's on a 2,000 calorie a day diet. She eats some eggs and 2 slices of toast for breakfast, and there's 13 grams of fat. What percentage of her daily fat has she eaten at the end of breakfast? Okay, so percent is part divided by whole. We have 13 grams of fat and 65 grams of fat. I say, RIPLOP. Why are my numbers floating today? Am I wanting to go into percent or out of percent? Into percent. So I'm going to move to the right. So she's 20% done. Should I do more of these? Is this important review, or can you do more of them at home already?
Yes.
Oh. Now, if you're not making me do another, I will at least talk through it again. So, the percent of an amount, part divided by whole, for that 90%. The whole is the bigger one, what she has total, and the part is just the part she's eaten at breakfast. It's pretty easy in this case to see which is which. Do my division, I get a decimal. I don't want a decimal, I want a percent, so split the decimal point twice. Okay, and there's also a similar one that doesn't appear as often on food packages for 2,500 calories per day. If you're someone that's more active and eats more, then they change the numbers a little. Here's somebody right in the middle. Arthur should be eating 2,250 calories a day. What should he do? Well, if he's halfway in between the 2,000 and the 2,500, then he could just average them, add them up and divide by 2, and say, aha, I'm halfway in between, so I'll take the average. Whoops, 21 is a below. Okay. I need to change that on my thing. I will make a note to myself. Below. Okay, that's for me. Okay, factfulness interlude. So, in the first chapter, you read about the gap instinct. That it's too easy to pick things as either good or bad, or cheap or expensive, or whatever, and forget all the middle categories, which in many real-life situations are the important ones. So we're going to think about food, and I'm not going to make you do this now in class because we did so much announcements. But we could say, instead of just good calories and bad calories, then think about 4 groups. You could have the best food is nutritious and filling. The worst food is neither nutritious nor filling. If you've heard about why high fructose corn syrup is so evil, especially for kids, it's because it doesn't fill you up. So you'll eat all of these junky calories and not even feel like you should stop eating.
Doesn't it inhibit your brain from being able to tell even if you're full by something else?
I don't know the mechanism, but yeah. And then kind of in between would be foods that are a little bit of this but not that. So it might be better from a health point to go through what you eat for a couple days and sort your foods into not just good and bad calories, but am I actually eating things that are nutritious and to fill me up so I'm not eating too much. But that's not quite math, so we'll skip that. Okay, and our next study skill to talk about are study groups. I'll do that real quick just because we're behind. So, if you go to a graduate program in math, it's kind of scary watching math students work in groups. My wife grew up in a family that was very conflict avoidant and would let things fester instead of argue, and so watching graduate students do math was just scary for my wife. She would avoid when I was in the building doing that. Because what happens is everyone is sitting together, working on the homework by themselves until you get stuck. And when you get stuck, someone jumps up and starts writing on the board what they are doing with this problem until they get stuck. And the other people, maybe they were on that problem, maybe they're not, but they see someone jumped up to the board. So they stop what they're doing if they're on a different problem and start this one also. Eventually, someone will get some other idea, so they'll jump up also. And they'll start arguing at the board. No, you should multiply by 3 here. Or no, divide instead of multiply here. Or whatever. But it's more complicated because it's graduate school. But you get the idea. And they figure out what's wrong. Eventually, everyone in the room agrees on how to do this problem. So then they can put that in their homework. And then everyone sits down again as if this never happened. And keeps going wherever they left off. So, if you want to have fun, this is obviously not the way to be social in a group setting. Hopefully your study groups are a little more laid back because you're not a crazy math graduate student trying to crank out so many math problems every day. But if you want the most efficient way to do study group problems, then try this one. Or if you're in a group and someone just keeps talking about something and you want to get a little more focused and say, hey, let's do this for a little bit. So, there you go. Okay, back. Back, please. Okay. Metabolism. So, now you know enough to do the calories homework if you haven't tried it, but a bunch of people have. You read ahead. So, metabolism. Since the 1970s, people have said, when you're exercising, don't overdo it. Your maximum safe heart rate will be 220 minus your age. That was a terrible rule. It was simple. Simple things are often wrong. So a slightly better rule, and if you click on the link, you can go to the PubMed article and read all about the research, is you take 211, go back, and subtract 64% of your age, so 0.64 times your age. We don't need these parentheses. The formula is going to prioritize multiplying by order of operations anyway. It's just there for your eyes to kind of see what's happening. Once you find that number, then you multiply it twice. It doesn't count as aerobic unless you're going half as much as that for your heart rate. So times 0.5 or divided by 2 for this answer, and you get your lower limit for aerobic exercise. when you're exercising, you don't actually want to push your heart rate to the very border of unsafe. So the recommendation is 85%. So take this number and then a second time multiply it, this time by 0.85. So let's just do an example. If Arthur is 35, then we'll do 211 minus 35. Whoops, I should follow the same order. Doesn't really matter. So 211 minus 0.64 times 35. I have to round. Uh, 187. Beats per minute. Then I'm going to divide it by 2. I'll just write it over here. And I'm going to multiply it by 0.85. So there we go. So that's a pretty friendly formula. Remember from our in-class activity with push-ups that what counts as aerobic, the reason we call it aerobic is that from then on, if you're more intense, it also uses that much more energy. If you double or triple your intensity, you're double or tripling how much energy you're burning. Okay, our next metabolism formula is a bit more complicated, but we have time today. We talked about those 2,000 calorie a day diets or 2,500. How do you know where you are? So, that's an interesting question. Somebody invented the word basal, like baseline, and they were researching the basal metabolic rate. So, if you are lying in a hospital bed all day and not moving, how much energy does your metabolism burn just for your breathing and heart rate and digesting food and everything else your body does when you're just lying around like a vegetable? So, what would that be? And this is an example of a pattern we're not going to find out, just like we're not going to exercise until one of us falls over from heart rate. This time because it's incredibly complicated. They did all sorts of things, and they found, Harris and Benedict, that the best way to predict someone's basal metabolic rate would be to measure the surface area of your skin. So combining your height and your weight, and just sort of the bigger you are, then the more metabolism you have to just keep your body going. That makes some sense. But that's not really going to happen. You could imagine going to the doctor's office and they take a bunch of stickers and put them all over your body and count how many it takes and so on. No. So we need a better way to estimate BMR than the surface area of your skin. So they made up some formulas based on weight and height and age and sex, and they work okay. But in 1990 they were updated, so I'm not going to tell you the more famous Harris-Benedict formulas, because then somebody is going to accidentally use them on the test and get in trouble. So we're going to use the more recent ones, the Mifflin-St. Jeor. If you're going into nursing, you will hear all these names. So sort of be aware of which things are obsolete and which ones are not. They're reasonably accurate. They get within 10%, which for this kind of thing is pretty good. They look different based on if the person is a woman or a man. They start out the same, multiplying your weight by 4.55, multiplying your height by 15.88, and then subtracting 5 times your age. Does it make sense that your metabolism slows down as you get older? So if you're a woman, that number is almost right. Add 5. If you're a man, that number is too big. Take away 161. Should we do Arthur or Odette? Let's save the other one for reviewing stuff on Thursday.
Odette, why not?
Odette, okay. So I'm going to take Odette's stuff. And I want that one. Again, order of operations means that none of these parentheses really matter. I don't have to put them in the calculator. They're just there for our eyeballs because the multiplying is already going to have priority. You'll see there's one bit of prep that I should do, but I'm not. So her weight is 110 pounds times 4.55. Her height, I can't do 5 foot 1 inch. Yeah, so the prep that I should have done, now that I know better, is I'm going to do my 5 times 12 and then add 1. Okay, everyone okay with why it's 5 times 12 plus 1? Each foot has 12 inches, and then there's one more inch hanging out. Okay, 30 years. There we go. Okay, now it's the calculator's problem. 110 times 4.55 plus 61. So I'm getting about 1,324 calories per day. Everyone's calculator agreed. Did I make a mistake? This is another of those issues where how much to round is more a real life issue than a math issue. The formula itself is only accurate to within 10%. So we know this to within about 132 calories. So you could round it to be 1,320 or even 1,300. And it would be hard to argue that you're wrong. But you might as well keep the whole number. There's really no reason to get rid of this. We're not sure if it's actually more wrong in the up or the down direction. So if you round it, you're sort of favoring up or down. Okay, we're not there yet. We want to know when Odette looks at her box of cereal and it says 2,000, here's a column, 2,500, here's a column, which column she's in. And this is just if she lies around because she has terrible flu and she's on the couch all day not moving. So we need to keep going. The DCI, daily calorie intake, is the rest of the formula. We're going to take her basal metabolic rate and multiply it by something bigger than 1, and that will make it bigger. The question is, how much do we multiply it by? And again, like calories burned for different types of bicycling, we could study this very well if we cared, but we don't. So we're just going to use a few numbers. The estimation we're using is from the World Health Organization, and they've discovered that, again, we're looking for like a 10% accuracy, so good enough if we just pick one of three numbers. Do you call yourself like a couch potato that gets minimal exercise each day, a normal person that gets a moderate amount of exercise each day, or a very active person that maybe has an exercise routine they do each day? Then, based on if you're a woman or a man, you get a number to multiply your BMR by. So Odette was what kind of person? Very active. So her number is going to be the 1.82. So we take the 1324, multiply it by the 1.82, and we get about 2,410. So Odette is a lot closer to the second list of USDA guidelines. She's almost at the 2,500. If you scroll down and keep reading, you'll get a warning that none of this applies to professional athletes. If you are someone that exercises as much as a professional athlete, it changes your whole metabolism in lots of ways. You might have heard stories of marathon runners who can't get pregnant because their body is just too into the exercise and so on. So this isn't the professional athlete thing. There's also nothing here about kids, right? We're talking about men and women. We're assuming this is adults because kids have a different metabolism. I can talk about that briefly. So you have things in your cells called mitochondria that are part of how you get energy out of your food. And muscles in kids don't have many of these. So when you look at a little kid and you're like sprinting along the street next to your 5-year-old and they start out going pretty fast and then they just peter out all of a sudden, then that's because their muscles don't have the mitochondria to make this energy as they're going along like yours do. And in the same way, when they get tired, they just sort of fall asleep, right? They don't have soreness. It's the waste product made by the mitochondria that makes your muscles sore. When you exercise a lot, you actually get more of them in your muscles. So if I'm used to running 1.5 miles for my running routine, and then I start getting tired and sore, that's because I've built up a certain amount. And if he can run 3 miles before he gets sore, then he has that amount. But if he tried 4 miles, he would be sore and tired too, just like if I tried more than what I've trained myself. So it's kind of strange, but there we go. Okay, other warnings. In case you haven't read the studies, exercising more is not a good way to lose weight. You have to change your diet too. If all you do is exercise more, you wind up eating more and it balances out. So you might be more fit, but you're not going to weigh less. And there is a myth in some weightlifting circles that if you exercise a lot, your whole metabolism will get elevated and stay that way. So you'll just burn more calories, not only because you've been pumping iron for half an hour, but just because you've boosted your body. That's actually only true for people that are both over 50 and who do both resistance exercises and aerobic. Then they can actually have a boosted metabolism. But if you're not in that category, like most of these guys pumping iron, then no, it's not going to work for you. Didn't know that. Okay, it's time to go. I'm just going to flash by 2 formulas because I have a minute that we're not going to use. If you go into nursing or go to the doctor's office, you'll hear about your body mass index. Here's a formula. We're not going to use it. You don't have to write it down. It is built to do statistical studies on groups. The fact that it's used to measure individuals and say if they are overweight or not is not the way it was intended. And we can talk more about that if you want. And percent body fat. That one I'm not even going to give you a formula for. There are plenty of formulas. They are all absolutely terrible. The 10% we got for BMR and DCI is pretty good. They are not at all within 10%. So I have some pictures instead, if you want to say estimate your percent body fat, it's actually more accurate to just look at pictures in people's abdomens than it is to plug in numbers. So there you go. Okay, that was the metabolism section. I'm going to stop the recording and